All right, welcome everyone to our first study session for the Token Engineering Fundamentals course. Today we will start by looking at the first module, but before we start, maybe I should just share my screen and then show everyone else what this entire thing is about. Let me get reoriented. Sorry, I'm working on the laptop and it's disorienting me. Not used to that. All right. So we're at tokenengineering.net, and what they have is a token engineering fundamentals course that they just launched earlier this month. And it's a 5-part series, 5 modules. The first is just an introduction to token engineering, which we will be looking at starting today. Second part is the process and discovery phase. And that is where we explore the environment in which we are token engineering. There we will be talking about things like platform design toolkit. If you remember from like our earliest mirror boards, we had some stuff going on there. And then the design process, which I have very limited knowledge about. Deployment phase, I guess that's smart contracts. And then governance, which sounds very interesting, and only a few people got enrolled, so we'll get there eventually. But today we're going to start with this first module. Let's see. I think I should be already enrolled here. Thank you, Google, for making my life easier. For that, I give you all my information. All right, so module 1 is an introduction, and it establishes the reasoning behind why we need this and the framework for how we approach token engineering. There's 5 main papers that we go through in this module. First is by Trent McConaughey, towards the practice of token engineering. There's a series of medium posts that he put up. And we have Foundations of Crypto Economic Systems, which is a very, it's an academic paper. Then we have the Web3 Sustainability Loop, where we talk about business models in Web3, how that works. There's a very short paper about crypto network governance as capital, which is very interesting. And then there's Engineering Ethics in Web3, which I didn't have a chance to take a look at, but maybe we'll get to that next week. And I think, you guys have any questions? If not, we can get started by looking at the mirror board.
Wow, these are some really extensive notes. That's amazing.
I tried to basically summarize all this stuff. What they did, the token engineering community, in setting out the course, is basically they just linked the papers and gave very limited information outside of that. So all we got to do is kind of go to the papers, which I've linked here. This is the first one. Can blockchains go rogue? And maybe we should just ask ourselves, can they go rogue? Or what are your intuitions on this?
What do we mean by rogue?
Yeah, I was going to ask that too.
Kind of got mixed up there. Alex, you were saying?
I mean, rogue is a very broad word. I don't understand.
So it kind of means, can it go off track? Can it just serve a purpose that it was not meant to serve? I guess. At least that's how I'm understanding it. Nora, you were saying?
I had a question on what rogue meant too, because it generally, like, if you go rogue, before you were following some kind of established agreement of something, and then you go off of that. So I guess, yeah, that's an interesting question. If we're talking about token economics, then I was at a conference yesterday and a lot of speakers brought up the topic of capture, adversarial capture, where some other entity decides to use something for their own gain and essentially takes it over and takes it off track, kind of like Web 1 was captured by Facebook, Google, Amazon, and became Web 2. So Web 1 was captured and lost its initial visionary kind of, let's spread information, let's do this. And now it's all about collecting personal data and selling you stuff. So yeah, that's an interesting question. Can blockchains suffer the same fate?
Alex?
Yeah, I kind of was also along the same lines, you know, it's like, okay, let's kind of define rogue broadly for us. So there are unintended consequences. Someone plans something like one thing, and then something else happens. Well, it's interesting. Like, what could say? What?
Sorry, I just typed it in wrong. This is the definition.
Oh, okay. What does it say?
Doesn't make much sense.
Yeah, because you see, it's first reference is to some moral principles, which I think blockchain as a, I would say, technology, yeah, it doesn't have really, or at least not inherently. And you know, you understand what I'm saying?
Can you repeat that?
So, like, you just opened the first definition of rogue, and the first was reference to like dishonest, you know, and dishonest implies some kind of morality, right? And then a rogue means like it does bad things, and then there is a question like what we define as bad things, you know, because it's yeah. What's in the article overall? Can you tell us?
So I think the definition that we should go with is this one: behave erratically or dangerously, especially by disregarding the rules or the usual way of doing something. And the important part, I think, is behave erratically or dangerously. And just thinking about Bitcoin in that way, well, I wouldn't say unpredictable. Bitcoin is very predictable, but just dangerously, I think that's the key part that we should be focusing on.
So if a blockchain is Sybil attacked, does it mean and if that specific chain that has been compromised is being followed, does it mean the chain is rogue?
Yeah, it may be. I'm not quite sure. Like, just jumping into the article will help us answer that question. But the article kind of asks this question: has Bitcoin gone rogue? And it takes a different approach to answering this question. Maybe we should just jump into the article and go through it. So let me just recall the article. Right, so it talks about how blockchains kind of remind them of AI optimizer designs, doing like machine learning systems where you're optimizing to solve a problem. And it's really difficult to get the incentives right. And the article kind of makes this parallel connection between AI optimizers and blockchains in that they're solving just an optimization problem. So the core idea there was designing objectives, constraints for an optimizer AI is hard. An AI with access to vast resources, yet has bad objectives, constraints could end badly for humanity. There it has the example, the paperclip maximizer. You guys know about this? So this is a very interesting topic in AI design, where just imagine there is an AI that is tasked with creating paperclips. If you don't constrain it properly, if you just give it, I want paperclips, give me paperclips, what it's going to do is it's going to destroy the world in chasing after paperclips. It's just going to maximize the number of paperclips. It's going to destroy humanity. It's going to use all our resources to generate paperclips. So that's what optimize is for. So because creating objectives and constraints for an optimizer is hard, like how do you tell a paperclip maximizer, I want paperclips, but I don't want to kill humanity? Like, how do you say that? Saying that is very difficult to an AI. And the parallel there is, this is pretty much the problem that we're having with Bitcoin. Because Bitcoin is an optimizer. What does it optimize for? It optimizes for network security, and it does that by paying people in Bitcoin to solve a basic problem, just a math problem. And in order to solve that problem, people are creating ASIC machines that generate that use up a lot of electricity, and that's what it's doing. It's doing that very well. There are many ASIC farms all over the world, just trying to solve that useless problem. So it's really good at maximizing paperclips. In this case, maximizing network security. But the thing is, is that clear? Is that argument clear? Any questions on that?
No. There's a game called Paperclips, and it actually models this idea. And it starts with, you create one paperclip, sell one paperclip. And then when you make enough money, you can add machines and investments. And eventually you bring technology online to create AI. And then you can bring on new technology to build rocket ships. And pretty soon you're mining the asteroid belts to create paperclips. And it spreads out through the galaxy, and you have probes, and then it takes over the whole universe. And then there are rogue AI that combat you because they want to make their different kind of paperclips because they've drifted a little bit. And then the game ends with either you win or the losing side creates technology to send you to an alternate universe that has no paperclips, and you can start over again, or you can win this game. And it just keeps going. It's very interesting to see that kind of idea of paperclips taken to destroying the entire universe because of runaway AI.
Well, this is awesome.
It's very addictive, and it's totally mine. All you're doing is making paperclips.
Alex?
This is what you describe in AI. I've met this idea before. I linked to a YouTube channel, a guy who's talking about it a lot, and he makes very nice metaphors, to just understand what's like the big idea behind it. And it's, so like it comes to modeling, and when you have a model of something, and what we're discussing, tokens, they kind of, I think, model economic relationships in a way, or maybe in part, some part of tokens will model economic relationships. And with the models, there is like a trade-off between model being too thorough, and then it's like intractable. Too much resources are needed to kind of understand what's going on, or at least to move the model, to do the calculations and predict the next step, for example. Or like you reduce the number of calculations and then you reduce the resolution of the model. So it's like it's more blind and it doesn't make so good predictions. And yeah, so I think it's
Exactly.
kind of, yeah.
So that really boils down to like designing objectives and constraints for these optimizers. Making those models is really difficult. It's easy to end up with a paperclip maximizer that destroys the world. So the argument there is, so this argument that since optimizing is hard, like designing objectives and constraints is hard, it's difficult. Bitcoin, oh, right. So I missed a part of the argument. Maybe I should make more clear. So imagine, just think about what Bitcoin is. Bitcoin is a bunch of distributed nodes, just people who care about Bitcoin mining, serving this organism that is Bitcoin, just making sure the next block is minted always. So it can be seen as like a stupid form of AI. And it's almost impossible to stop because it's serving, it's making sure it lives on by paying people. And you can't really stop it. It's just going to keep going. So it's very similar to this paperclip maximizer in that way, but it's just dumb, just like the paperclip maximizer. So does that follow? Like, does the similarity with the AI, the paperclip maximizer and Bitcoin, does it follow? Because it leads right there to this. We have a life form that we basically can't stop, which is optimizing maniacally for that most precious resource in the world, energy. This life form is called Bitcoin. So what happens if Bitcoin goes to 1 million US dollars and the amount of energy that we use to mine Bitcoin goes through the roof? It spends more energy than possibly China. What happens then? Does that mean Bitcoin has gone rogue? After I read this article, I said like, oh yeah, okay, I'm gonna sell my Bitcoin. I decided to.
Yeah, that's an interesting perspective. And being part of Cardano for Climate, I've also like thought about that, like how much energy Bitcoin uses and whether it's even ethical. And that's kind of the point of this, is like if you optimize for one thing, you don't have other things in there like ethics or greater purpose or broader level of stakeholders in the thing. And then it can get very dangerous, as we're seeing with Bitcoin. It could totally go rogue because people seem to be doubling down on it as a like digital gold almost, which wasn't its purpose originally. People are buying and holding it, and that makes it more valuable just because people are doing that. And that, yeah, I don't know, it's interesting to think about it like that, as a life form that can't stop.
One implication of this was like Satoshi had to think about how do we change this system if at a future point we realize that something was wrong. Like he had to kind of figure that out early on, and he hasn't really. And the people who are within Bitcoin, the miners, the people who have the most stake in Bitcoin, they're the ones that don't want the system to change because they're benefiting. The more Bitcoin goes up, the more they benefit. The more risk we have as humanity of just having crazy stuff happen because we're running low on energy. Like every time Bitcoin goes up by $10,000 more, it spends more energy because more people jump in and create ASICs. This is pretty crazy. So we had to kind of figure that out at the beginning, but you know, hopefully Bitcoin doesn't go to 100K. Any thoughts on this one? Now we can go through to the second paper.
So one question, one small question. So if a blockchain specifically is bad, as has gone rogue, does that mean the cryptocurrency on the blockchain is also rogue? Because I was listening to Charles recently, and he was speaking about how Bitcoin can be wrapped and moved to Cardano and can be used there. So is there a differentiation we have to make there?
Well, in this specific scenario, does wrapping it mean we're not mining it anymore and the energy costs go down? If so, I guess there is a difference.
Yeah, absolutely. So we are moving the Bitcoin, the cryptocurrency, wrapping it and moving it to Cardano. So it'll be proof of stake, but it'll still be Bitcoin.
In that case, I guess we figured out how to prevent it from going rogue.
Charles figured it out, but okay.
Oh yeah, it's like Charles did it, we did it, man. Yeah. Right, so
I think we cannot do that because Cardano is a company, and it's open source, but not open and directed. But Bitcoin is somehow different than this. It's open source, and nobody is managing right now Bitcoin. There's no boss at all.
oh no. I'm just learning how to use a Mac. It's difficult. As an avid Mac hater for 10 plus years.
Yeah, until you learn it.
Yeah. All right. So the second paper kind of is the foundations of token engineering, I think. This is cited as the Medium article that sets out the stage for what token engineering is. Right. And it starts out by just looking at related academic fields and why it came up with this name, what it means. And it starts out with this video. You guys are familiar with this one? This is the Tacoma Narrows Bridge collapse. Well, do you guys see it? Or I just,
No.
I stopped sharing, right? Oh, my bad, one sec. Let's see.
The wind is a powerful thing.
This is some crazy stuff. Galapungurdi. This is what happens when you don't engineer stuff well. You don't take care of the edge cases. And I think at some point it just is destroyed. Right, so Trent McConney, the author of this paper, sets this out to show us like we are responsible as the engineers of the systems we're building. If it's civil engineering, we're responsible for the bridge collapsing because of resonance. And if we're token engineering, we're responsible if stuff like Luna happens. If people lose thousands of dollars like life savings because you didn't account for an edge case. So the ethics really comes into play as we're looking into these systems. And after that, it goes into related fields. So these fields kind of come into play when we're thinking about token engineering. And I think we have some, we all have background in some of these, but none of us have an understanding in maybe even more than 3 of these. And that's the beauty of this new field. It just has so many different things jumbled into one. Does this remind you guys of anything? Does this like tell you something about the field? Any comments on this?
It's interesting because, like, you know, they put electrical engineering. I first thought about, like, why the hell electrical engineering, you know? And then, yeah, there's plenty of optimization problems in this field. I'm not very familiar, but yeah. It's not obvious, but yeah, I think it's a nice list.
I think Jem can tell you exactly why electrical engineering. Like me and Jem, we're both electrical engineers, but he is an electrical engineer and I'm just a guy who studied electrical engineering.
Yeah, for
So-
many years.
Your opinion on why it's connected, like how electrical engineering is connected to
What I can say about this, it's directly connected because we have very similarities in electrical engineering and the token engineering, and it relies on some kind of imaginary values that we use in electrical engineering with what we call I, and we don't know what is it doing right now. And token engineering is the same. We have some behavioral psychology next to it, and we have some values. People put values to the tokens, and it can be everything and it can be nothing at all. So they are very similar in that case.
There's some fields in like electrical circuit design where you're trying to optimize how your circuit is behaving. And in that way, there's some similarities. Control theory, like cybernetics, this sounds like something else to me at least. But well, but cybernetics means wide-ranging field concerned with regulatory and purposive systems. So that doesn't mean anything. Let's see. I think robotics, basically. Well, what a robot does, regulation of a system, that is pretty much electrical engineering. There are some similarities there. But the one I like complex systems also, and economics, of course, because we're thinking about money in general. Game theory, because we're designing, we're designing systems where agents are going to behave according to game theoretical principles. Computer science, because, you know, code, I guess. And even psychology, that is tied very close to game theory. And he suggests some alternative names here as well. But I think the important bit, let's see, is it's called an engineering because it's rigorous analysis, design, and verification of systems. And coming back to that video, it's about ethical and professional responsibility. And he's trying to establish that if this is an engineering field, that there's going to be that responsibility. If it's just economics, there's that responsibility is not there really. Oh yeah, and there's this connection with game theory and mechanism design. And by the way, you guys getting much noise from me? So I can just move. It's raining out here.
Actually, your voice sounds fine to me.
All right, that's good. It's getting really loud here. It's raining. Right, so Trent makes this connection between game theory and mechanism design. This is a phrase that's going to come up very, very often. So, you guys familiar with what game theory is? it just basically means within a system of rules, within a game, for example, within chess, within rock, paper, scissors, anything that we can define by rules and behaviors. Game theory gives you the optimal set of behaviors that you should take within the rule set. That's what game theory is. So with, for example, with rock, paper, scissors, game theory tells you your best optimal move is to play randomly, and that gives you the best chance to win. Mechanism design is the reverse of this. So it says, given an outcome that we want, what game should we design such that we reach those, what is called optimization design, which is just basically optimizing a function. And these two things are very connected. So when you see game theory, just think reverse of mechanism. Till now, am I just talking to her, or am I making sense?
Hey, Chakan, is your voice is breaking for me. Is it the same for everyone, or is it just
Oh,
me?
it's getting so. Yeah, I might be
Yes,
getting
it's
cut
the
off. I'm
same.
saying. How about now? Is it good?
Yep.
Hopefully, it was just a momentary thing. It got disconnected for a while, but does it make sense so far? Any questions so far? Anything that doesn't make sense that we can look back over?
So in
Yeah.
specifically,
Is it good? Should I continue?
yeah. Hey, Chakan, can you hear me?
Yeah, I'm gonna change one moment.
Okay, cool.
Hey guys.
Yep. I can hear you.
Okay, good. I just
I
changed
think
network,
he-
so hopefully it's better now.
Cool.
I think I got cut off. So what's the last thing I said that you guys heard without me getting cut off?
Yeah, that's the last thing I remember, but I can't remember exactly what he said before that.
Right. So the idea was that game theory. Do you know what this is? What is game theory?
Yep. I think we heard game theory and the opposite of it, mechanical design.
All right. Awesome. So mechanism design is the reverse of game theory. Game theory is analyzing games to find the most optimum outcome, and mechanism design is designing so that you do get that optimum outcome. So what we're doing when we're token engineering is basically mechanism design. So we say, okay, I want to launch this thing called Bitcoin. I need it to be safe
I need the network to be secure. How can I do that? How do I get to that outcome? And you design it so that people come and build ASICs to secure your network. And if you're interested in this stuff, it's like CS, like heavy computer science stuff. This economic game theory course is will get you through that mathematics and give you all the background needed to understand this stuff. Right.
So I have a question here. When you say optimizing design, and you said we are optimizing energy, right? So are we optimizing energy specifically that machines are consuming, or are we also considering the energy that humans expend?
Oh, that is the case with Bitcoin, where we're optimizing. We're not really optimizing for energy, actually, with Bitcoin. We're optimizing for network security.
Mm-hmm.
I think there's this bit. Let's see. Where was Bitcoin? So Bitcoin is optimizing for this, right? It's optimizing for this contribution to security.
Oh, okay,
And the
okay.
secondary effects of that, because it wasn't optimized for,
Mm-hmm.
is just ever increasing energy costs. It's not in this function. It's not
Okay.
optimized for.
Got
Because
it,
that's
got
the
it.
case, we end up with crazy rogue Bitcoin.
Got it. If not for energy, what else would we optimize for? Like in other scenarios, it'd be security, energy. It's like the trilemma things, is it? Are we usually referring to those three things?
Well, I think that changes depending on what the ecosystem is, what the utility of the token is. But if we're thinking layer ones,
Mm-hmm.
it's security of the network that we're optimizing for.
Mm-hmm.
If we're thinking something else, like give me an example of the token we know. What can we think about?
So if you have to design a token for littlefish, what would we optimize for? Like, I'm just giving a random example. It'd be too hard, maybe, but
Right,
I don't know.
I guess it would be collective action potential we would optimize for, but I don't know how do we put that into numbers. But
Yeah.
coming to an example that we all know, I think, is IPFS. IPFS is storage. It's a database that is kept decentralized in a decentralized manner. So you have to incentivize the storage providers to keep the data. Like that's what it's optimizing for. It's optimizing for how long the data is kept and how much redundancy there is. So you want 5 providers to keep the data. So that's what you're optimizing for. So it changes depending on what you want.
Got it. So
And
it's a context-based thing. Okay, got it. Yeah.
Exactly. And that's the purpose. Like what we're trying to do is optimization design. You're trying to decide what we are going to optimize. And this guy, if you don't know, Simon de la Rouvière is very influential influencer, I guess. I don't know. He writes a lot of stuff. But this is the stuff that he came up with in this article that was from like 2018 or something. It says tokens have reduced the cost to tokenize coordination by orders of magnitude. And thus we are likely to see the effective tokenization and by extension, the introduction of markets into almost everything. Like this is an incredibly important insight. The value of a coordination system is greater than the cost of coordinate. Yeah.
Just wanted to say something about like what you said about optimization, Harsh, yeah? And there's like, so if you have a token, right? Often you would design it around a market, right? And then in the market you have, like in a simple case, imagine you have 2 parties, yeah? Like somebody wants something, there's like whatever. And then if you consider all the like users, agents who are in this market, the consideration of the token is like what they optimize for, you know, so that you can kind of drive their behavior, and that's with a like mechanism design idea. You know that like how do you make people charge electric scooters which you rent them out, you know, and like yeah, okay, you fill back their like usage minutes, you know, and guy just riding around the city on one scooter, bringing others to the charging station, you know, because after he can ride 1 week for free or something like that, or get some money, you know? And that's like what the users optimize, and like the designers of the token is like consider what the hell people are optimizing for, and it's like very deep conversation because the values, you know, and what are the values of us or users of whatever, you know, can talk forever.
Makes sense.
And that connects to like the behavioral psychology part of this.
Yeah, it is pretty scary because like almost all non algorithmic stable coins like use psychology, and like pretty much all of them are kind of like breaking. So yeah, it's pretty scary. I agree.
Yeah, but look, you can have, for example, a very complex idea. You have algorithmic stable coin, yeah, and that's like you have to design it properly. But then look from the other way. It has its complications, but still, like if you look at the token as just sharing equity, right? You issue 100 tokens, and you get an investor to pay $100 million, and you invest into like a random choice ETF, you know, and then your 100 tokens is worth $1 million because like they just represent the ownership of parts of the like equity fund.
Correct. Yeah. Makes sense. Yeah. Chikan, are you listening? Invest $100, make $1 million. That's why I'm going to invest $100 in littlefish token.
Oh yeah. Not sure if you're going to make 100 million. I'm thinking 100 trillion for each, but you know. You laugh now, but you will have inflation reach there in 2 years.
Oh yeah. That's regular money. Yeah, that's true.
Oh man. Hopefully, yeah, we're gonna get there. I'm taking a look. Maybe some of this is a little too technical. But basically what Trent is saying is token design is similar to something called optimization design. And there is an example called evolutionary algorithms, which is basically just like how evolution works, but AI. So you just have many agents searching at once, and they do just random mutations. And some of the mutations are better at solving the problem. So they have a metric that gives you a better number. And you pretty much kill the ones that don't do well, and you make sure the ones that do well live on. And that's evolutionary algorithm, just like evolution. Like if a species is bad at living, they die. If they're good at living, they continue. And that when that happens many generations, you got a really good solution to a problem. And token design is kind of like that, he says, and makes that parallel. And it makes that parallel in different areas. So for example, looking at the goals, a tokenized ecosystem might say maximize hash rate, so maximize network security. And the objective function in an evolutionary algorithm would say minimize error. So these things are very similar. So going with that analogy of this is kind of like optimization design, it's kind of like evolutionary algorithm design. Trent comes up with this, I think, 3-step methodology. And the critical bit is this. Step 1 is formulating the problem. Like, what are the objectives? So what are we optimizing for? What are the constraints for your token ecosystem? And this can be multiple objectives, single objective, zero constraints, multiple constraints. And the thing is, this is like an iterative process of defining what those are so that
we can understand it. And the questions we ask there are like, who are my potential stakeholders? What do each of them want? What are the attack vectors? And the attack vectors we try to minimize with this, with the understanding the objectives and constraints. And this is where, coming back to that platform design toolkit comes in, like understanding these, like step one is asking us ourselves, who's important? What do we want them to do? Who's going to attack the system to abuse it? That type of stuff. And the objective is to turn this into the basic objectives and constraints. And then step two is trying an existing pattern. Like if you want to build a stable coin, there's an existing pattern for that. If you want to build many different stuff, like there are existing patterns already out there. And if they don't work, you go ahead and create your own pattern, and then that becomes a new pattern. And basically that's how you approach this. It sounds simple, but even this is like super difficult to do. You guys want to take a look at all the different design patterns that he lists out, like what is out there?
Yeah, sure.
So, I didn't deep dive into any of these. It's kind of very cloudy what these each are, but there are many patterns on curation. There's stuff like curated token registries. Maybe you heard about those. I'm thinking about it as like, how do we get a decentralized Reddit to be moderated properly? That type of problem, I think, falls into this area. And there are many different patterns to use there. But this is from 2018, I think, so this is very outdated. Probably there are many, many more on this. But if we're thinking like governance and software update designs, there's stuff like Aragon now, Colony now, third-party arbitration. There's this thing called Ethereum. There's proof of human or proof of compute, which is kind of similar to what we have with actions. In Steemit, they have, this is like a social media that they're using, that they're creating. I can't remember what this is. On Filecoin, it's proof of space-time. So this is what, this is the model that they're trying to optimize for, that you stored the file. And many, many other stuff. And he says reputation falls between curation and identity, which I didn't connect that dot, but there it is. And there are a bunch of different resources that you can dive into that I found by just looking into it. These are just like different building blocks that have arisen from token engineering. So there's this refungible tokens. No idea what it is, but it seems important. There's this token lexicon, which was a good resource, if I recall correctly. Oh yeah, gives you lots of definitions. I think there's this one seemed really interesting to me. So someone can, if one of you wants to go into it, you can read this one and give us an overview of this article. And I think this is the all end all of these resources, because it has almost everything from 2018, 19, like many good articles. Only have to read all these to understand what token engineering is. Super easy. All right, so, all right, sorry, I kind of missed the main idea of all this. And that is like, inspired by software engineering patterns, we can document emerging patterns for token design. And that's what we should be doing as like a field of token engineers.
I guess there's many progress in this that we got to catch up with. And I guess we will be catching up with in the future modules. Right. Any ideas on all of this? Does that make sense? Or did I just jump around too much?
No, that makes sense. Maybe for the next meeting, we can just like each of us can explore like one type of like pattern, one different type of pattern, and like have like a write up on it and like discuss it.
Oh yeah, that would be awesome. And the final thing he says, okay, so he started with token design as optimization design. So we got to formulate the problem as objectives and constraints, and then try different solvers, which are just design patterns that we use. And then the final thing, once you do that, you simulate your system, and then you see if the thing that you built does the thing that you want. So we need things to simulate the system. And that's where things like token spice come in. So if this is similar to, what was it called? Jim, do you remember what the thing that for in simulating electrical circuits was? Something spice? This is this kind of resembles that.
It was with something spice, but I don't remember.
Yeah.
Exactly.
This is
Spice works. No. Yeah, I'm sorry, I don't remember it.
Oh yeah. So this is modeled after that. It's basically like you simulate tokens, how they behave. And there's CAD, which is another simulation, but the most fun, and I think this is the one that we can all learn. And this is gonna take us like 5 hours to learn. Look at this, it's just a game. You can simulate any complexity system with this, machinations.io. Its original use case was simulating like games, like strategy games specifically. You can simulate any type of game, but specifically like game economies, you can simulate with this. Like if you've heard of a game called Europa Universalis or Hearts of Iron, or like even Age of Empires, you can simulate with this. You have agents that take behaviors, and then you can have a full simulation of what happens. It runs a Monte Carlo simulation. So we can learn this together and then simulate whatever we want to. Like we do crazy stuff with this. So I think this will be the main tool that we'll be using because we can all understand what's going on. And it's got very good docs that we can, like if you just want to jump ahead and learn this and teach us, that'd be awesome. And this allows us to simulate, verify, and design and explore what we want to build. And together, if we do all this as a field, then we might have a practice of token engineering is what this paper was all about. Right, any comments, questions?
So I was just like really, I mean, I thought the thing that you just showed where you simulate like the game economics, I thought this is really cool. How do you simulate human behaviors or actions with this? I mean, maybe that's too complex a question to ask.
I think we can just do a basic demo, or maybe just look at its docs and see what it is. Documentation, that should get us what we want. Right, start here. It's going to show the very basics, and it's got a very, very cool. So it's a very high level thing. It has sources. Source like provides. So you can think about like this is a source for money, right?
Mm-hmm.
It gives you like one money every time I click it. You can do that, or one money every second, or if you have a drain takes away your whatever, and you can have different types of resources. You can have money, you can have X, you can have Z. Pools collect those, so sources and drains are connected to these. So the drain decreases or increases the value in the pool.
Gates distribute, I'm not quite sure what that means. Traders exchange, I don't know what those are, but it's not really that complicated. Once you like spend 5 hours, they said
Mhm.
5 hours is the time to learn the basics. Like you can learn it in 5 hours and go have
Oh,
have an understanding. So, and it's easy to learn. Like, look at it. Basic action the player performs is kill enemies, right?
yeah. Okay. Okay. Makes sense.
Can I kill enemies? Why can I kill enemies? Oh, all right. I have best play. Right.
So
So-
what? So okay. So is there like a, how do we know if like a system doesn't work? As in, if it's a system that fails?
Right. So you have to simulate it. So you build the system, and then you're looking at some numbers that you set up
Mhm.
that you're optimizing for, and you're looking at what the numbers end up doing with that simulation.
Oh, okay. So we need to have like the optimized numbers in mind, and then based on that we compare, is it?
Well, you have an idea of what the expected behavior is, and then you
Mhm.
take a look and see what happens,
Got it. Got it. Yep. Yep.
basically. But what you want is probably like if you're like simulating so that you're looking at all the individuals and
Mhm.
how much like Bitcoin they have. Maybe
Yeah.
what you want is Bitcoin to be distributed even-ish. And if your system ends up like in monopoly, one person has everything, oh, you say like, oh, this sucks, it didn't work out. That type of deal. But much more
Mm.
complicated, isn't like, what are you optimizing for? In our case, we're going to try to optimize for, yeah, let's optimize for collective actions. What does
Wow.
that mean?
Yeah.
Right. So please jump into this. Like, this is really simple. And there's some
Yeah.
good resources to learn this. Like, if you're interested in this, just learn this and teach us. And that would be super cool to learn. And there are some templates in this as well. Like, if you want to do like an NFT marketplace, there's already a template for it. If you want to do an AMM, there's a template for it. Like, you're not going to start from scratch. It's really good. All right. And the final paper in this towards the practice of token engineering from Trends is a case study of Bitcoin and a case study of the thing that they were building that he actually came up with this article from called Ocean Protocol. And the first thing, Bitcoin, right? You already talked about it, but the objective function is to maximize network security. It's a very simple function. Is this, I mean, security is compute power. That's how it defines security here. And the objective is to maximize it. And there are, I think, let's see, there are no constraints. There's only this objective function is maximizing network security. And what are the results out of just very basic objective function of maximizing network security, which is maximizing compute power? Super secure, lots of mining, like it's so secure. The hash rate is above supercomputers. There's an entire ecosystem that's been built around it. It started an entire like field, cryptos, blockchains, and the electricity usage is just higher than many small countries. So very effective. There's just one objective function is effective at doing many different things. But take note that your objective was network security, and then you also did this stuff. So you have some side effects that you didn't really account for.
So can we optimize for only one thing at a time, or can we optimize for multiple things?
So you can have multiple objectives and multiple constraints.
Okay.
So like you can say, my objective function is to maximize network security, but I'm also constraining maximum energy usage. You can technically say that, but how you implement it is you probably can't implement it.
Got it. Yeah, yeah.
But theoretically, it could have optimized for maximum network security plus maximum minimum energy usage. It should have been possible, like technically, I guess. I'm not going to go into this one, but he talks a lot about like Ocean Protocol and what they did. And this is what I've been talking about, like platform design toolkit.
maybe we should take a look at this. You guys familiar with this one? I'm guessing you're not. Let's go into it. Let's see. Platform design toolkits, an end-to-end design framework optimized for multi-sided ecosystems. So basically what it is it's just like tools like these that you can use to understand your ecosystem, whatever you're building. It allows you to understand who your stakeholders are, what your ecosystem is, and just answer questions about your ecosystem, basically. It's really cool. So we're going to be doing this as part of this study group for littlefish to understand what our ecosystem is. Like Jem has already worked on this way back in, I think in January. Then we were trying to build it for a Kibo-like DAO idea. But we're going to redo it to understand what we want to do. And he goes through how they did the constraints and all of that, but it doesn't really matter. Right. I think this is a good time to take a breather at least, maybe take a break. Let's see where we're at. I'm just gonna pause the recording to let me just share my screen. Right, so the second one is this paper, Foundations of Crypto Economic Systems, and it's an academic article. Just taking a look at it, it's it's just a bunch of writing. I read all of it, but didn't come back to summarize it. But basically what it does, very high level, you don't really need to read this, I think, is outline what this field resembles. And there are some very good charts that kind of gives us what this is. So crypto economic systems like Bitcoin are economic systems, that's a subset, which are part of social, which are part of complex, and which are part of just systems in general. And maybe try to make sense of all this. Economic systems are, I guess, systems in which there are agents that are optimizing for their utility. So you're just a rational agent spending your money, trying to decide what you want to spend it on. Social systems, I guess they take into account human behavior. Not quite certain what the difference is with the economic, but I'm guessing that takes into account the psychological, behavioral economics would go into maybe here. Maybe Sebastian can tell us about this, but complex systems, I know what that is. Do you guys remember the discussion about complicated versus complex? You know what complicated is and complex is?
Yeah. I mean, English, right? Like the difference in English words, right?
Yeah.
Yeah.
Tell us.
One is like hard to understand. One is just complex. Like it has like a lot of moving parts.
Right. So give us an example of what a complicated thing is.
So yesterday I've been trying to write like my first line of code, and they gave some math problem, and I did like a repetitive, like divide something is like actually like divided multiple times. But instead you use like a short something function, and then it divides all those things in one little line. So I'm guessing one is like a complicated system, but complex systems would be like using multiple functions in the same this thing and like getting something, or multiple optimized functions, that is.
So you writing
my
code?
My explanation is complicated. Yeah.
All right. Yeah, it's difficult to understand. Nice. You writing code is a very good example of being complicated.
Yep.
Like it's difficult to write code. It's complicated, but an expert who wrote it for 30 years, it's not complicated. They understand it. It's just difficult to understand. But what about complex? Give us an example of what complex is.
complex would be like your car, because there are multiple little machines working together to make this car. So it's a complex system is my guess.
No, that's a complicated system, because if a mechanical engineer takes a look at the car engine, they
Uh-huh.
know what's going on. They can compute exactly what's going to happen. It's just
Mhm.
difficult to know because it's mechanical engineering. It's a
Oh.
complicated system.
Hmm.
So the
So I have
basic
no clue what complex means. Yeah.
the basic difference is, with complex systems, you can't compute it. You can't predict, like, to minute detail what it's going to do. But with complicated things, you can't. We can know exactly what an engine will do. But Sebastian says a complex system cannot be reduced.
So
we
that means
can't.
it's already optimized. Like, is that what it means?
So,
Mm,
can you guys hear me?
Yes. Yes.
yeah, we can hear you.
So a complex system is one that cannot be reduced into parts, right? So the most fundamental thing we are taught in engineering or economics is when you have a difficult problem, you break it into parts and then you analyze each of those parts separately. And when you put all that together, that should give you a complete model, right? A complex system, you cannot do that because there are properties to the system that only emerge when all of the parts are in interaction. So if you break it down into smaller chunks, whatever you are left or whatever analysis you can do of that doesn't represent the actual functioning of the system. So it cannot be reduced.
Okay, that makes sense. That does make a lot of sense.
I usually think that a complex system is built out of small small things that are more simple, but now you've really put a nice spin to it, which is the properties that only arise when it's all together. So thank you so much.
Yeah, yep, I agree. Yep.
Awesome. Thank you, Sebastian. So maybe giving you an example would make it even more clear. In org labs, this complex idea comes up in many different scenarios. And we talked about this in like organization design, complicated, engine, complex, traffic. And human organizations are also complex, so you can't reduce it. You can't think about it in terms of just individuals. You have to think about the whole. And these are predictable and controllable to the people who know it, and these are not. Could you also expand on this idea, maybe, if you can, Sebastian? How crypto economic systems are economic and social systems.
Is that from one of the papers? I haven't read all of them.
This is from this paper, The Foundations of Crypto Economic System.
No, I don't think I made it to that one. I've read the first two.
All right, then we can jump into this. So they analyzed what crypto economic systems, like this token engineering field, is similar to, what it kind of contains. Kind of an analysis that we looked at in the first half. So it kind of contains some industrial and systems engineering, some operations research and management science, economics, game theory, philosophy, law, ethics, political science, governance, psychology, decision science, computer science and cryptography, AI, optimization, control theory. So it contains a bit of all of those things. They found similarities within these fields, like these academic fields, in crypto economic systems. So you kind of need an approach that brings together all of these different fields, which is just, you don't have that in today's world. Like someone who's into computer science isn't into political science. There's completely different things. But this field kind of necessitates that. Does this follow? Does this feel intuitive to you guys, or doesn't make sense that this brings all of these things together?
I mean, it doesn't feel intuitive, but it definitely makes sense.
political science, for example, how does that feel to you within, let's say, Bitcoin? We talked about Bitcoin, the system. What it does is it's maximizes the security of the network. And how does political science come into play with that? So in Bitcoin, like how Bitcoin is regulated, how it's governed, it's decided by the parties, the stakeholders, right? And once you have a system like that, you have politics, because different stakeholders have things they care about more. Miners care about something, users care about something else. What other parties are there? Some companies that are built on Bitcoin care about something else. All of these are different groups. And that's why you have politics that kind of try to influence all of that. If you think about the block size wars, for example, it's a great example of like political science. Like you can analyze it with a political science framework. So that comes into play. Any ideas on this? Or should we skip ahead to the next paper?
I think it's just interesting that it's a bit like saying that math or statistics is involved in all the other fields. So crypto is a bit like although you're presenting it as a convergence, I'm also seeing it a bit as a base layer. Does that make sense?
Math is at the base of all or most of these, you mean?
Yeah, math or statistics, and, not normal distribution of things. So you can use math in almost all of these, or logics and all that. So crypto it's a convergence because it can be useful. I think we could say because it allows us to implement that math and those things at the service of all these areas of business.
Oh yeah, I love that framing actually. Yeah. So math is the foundation of like all of these, maybe not this one, but most of these. But then in crypto economic systems, you can convert political science and governance into math.
Yeah.
Philosophy into math.
It's a bit like when you're in school and you have math and you have physics, and you can sort of feel like everything you learn in math is basically what you're using in physics. It's like the trajectory of a projectile or something. And it's sort of like crypto is applied. It's like math materialized as a tool to serve all of these areas. Mostly all of them, I would say.
Yeah, it feels a lot like functional programming, where everything you decide in real life has to be converted into a function and then used for some reason.
So for example, in the law and in ethics or philosophy, maybe not so much on the mathematical side of it, but surely in terms of inferences and I don't remember, but the components of philosophy, if this and that, then what is the result? So the logic part of it, like the functional programming, like Harsh is saying. So crypto can help a lot in that. I think Haskell is one of the main pillars of this, right?
Is Haskell a pillar of this?
Haskell I'm referring to that because I keep hearing that Haskell is functional programming. That's very, very different from the standard programming that we do, where you're just basically constructing, I don't want to say objects, but you're just constructing a logic that's either going to be true or false. That's going to be sort of like in terms of philosophy, when you say, if this is true and that is true and those two relate, then the result is true or not. So that's what the type of thing that I'm expecting to find when I dig further into Haskell.
Makes sense.
I think when you look at Haskell, you can think about it as just pure math, because it's functional programming. It is lambda calculus, which is just a branch of mathematics. So you can't just think about it as anything that I write is math. I don't think you can do that with other programming languages.
Yep.
All right. So this I think was the most technical of all this. So I didn't really summarize it, but we can go into papers 3 and 4, which are more general. So this one, Web3 Sustainability Loop, is again by Trent McConaughey, who wrote the first one. And the idea is asking this question, like, how do we grow the ecosystem and make it truly self-sustaining? And this is talking about, like, if you launch a token system, how do you make that ecosystem self-sustaining? Like, how does it not be Ponzi? Is what it's trying to do. And the core idea is having this sustainability loop, where the core idea of the loop is to direct both network revenue and network rewards to work that's used for growth. So you make some money from the network, those are rewards, and you make that to grow the network by just doing work, developing it, doing what work is necessary to keep that thing going. So network rewards help to kickstart the project and to ensure decent funding. Network revenue can help to push growth further once the Web3 project achieves traction at scale. And this is talking about, like, launching tokens. So that's your network rewards. And any taxes that you cut on the transactions. And I think this has some really good models that we can take a look at to understand rather than going through piece by piece. But it's talking about business models. Gives this business model for Amazon. Maybe you guys are familiar with this. It's how does Amazon work? This is the Amazon flywheel. So Amazon grows by this structure. So you lower costs, that lowers prices, that's better customer experience, that's more traffic, that's more sellers, that means more selection and more options for the customer, and that's more customer experience, and that all leads to growth. And that's the Amazon flywheel. And you kind of need something like this for each business, is the basic argument. And it gives you the argument for, like, how businesses work. And this is the basic model. So you have some money that is decided by the company management where the money goes, and that turns into work to grow company revenue. Workers are the company employees, they do the work, and that turns into a product or service, which turns into company revenue. And if you do this well, this keeps growing. But this is the basic business model. You also have something else. You have stocks, which he says are the superpower for businesses. The company can issue stock, which means they can borrow from their future, I guess. No, not quite. Like, once they issue stock, they can have an extra injection of cash, which they can use to grow the revenue and grow this company's stock as well. And they have this payment. And you can kind of think about this very similarly with tokens, because you have very similar dynamics. Instead of a stock, you have the token itself, and you can build in taxing the stock. You can build in rewards. Like, if you put your Cardano into an SPO, you get interest. That's kind of similar to shareholder rewards. So that's the idea behind this paper, analyzing those things. It also analyzes governments, and again, very similar. You have the national government curating where the money goes, so deciding where, how to spend the money. You have the workers, who are the employees and citizens. You have work that goes to increase your GDP for the country, so it increase the value of your fiat currency, or like the total value of the fiat currency. And then you have national revenue, which comes back into the government budget as taxes. And that's the basic model. But also you have very similarly, instead of issuing stock like we did here with companies, governments can issue fiat currency. And again, the same cycle. So printing fiat will allow governments to supercharge the cycle, increase their curation potential, the amount of money they have, so they can increase their national revenue, their GDP. And what Trent does is, by looking at these models, tries to understand, okay, what does the same model look like in token ecosystems? And I think we're all intuitively familiar with the model by now. So I'm going to jump into here. I think this was it. The Web3 sustainability loop. What does it look like? You have token generation. Then you have a governance system. This is up for debate what that governance system is. It says vote on dollar allocation. I'd say do something else on governance. But basically curating how that money is spent on the growth and the mission. The workers, they do the work, the devs, the designers, the engineers who do the work. And once you do that work, the network revenue goes up, the value of the token goes up, and that feeds into more money to be spent. But the good thing is the ecosystem has network revenue and they can buy and burn the token. So this is their superpower. You can have if you're building it sustainably, you want it so that you're not generating the entire token at once and giving it all, but over time, you're allowing the money to be filed in to the workers who do the work. So this is how he outlines it. Web3 sustainability loop. Projects are proposed and curated by the community. That's step one. And those projects are funded by network revenue and network reward. Step three is projects do work and add value. Network revenue goes up, token goes up, and ever more funding goes to community. So it's a, what's it called? It's a growth loop. And this kind of implies a few constraints on what you should be doing, which is like the projects you select should add value to the ecosystem. So I think this is a great example that we can kind of take a look at. Is Catalyst sustainable with this model? Does each project add sufficient value to the ecosystem on average?
If you're asking like an opinion, I think no, not yet.
Yeah, so we're wasting money. So we're draining money out of the ecosystem. Or are we? So if one of the projects go bonkers successful and increases the average up to whatever, is it worth it that you wasted all this money on all this other stuff?
It doesn't, but return on investment, how are we calculating? Are we calculating it financially? Just say in terms of Catalyst, how would you calculate return on investment?
I guess token price maybe, or the value of the businesses on top, maybe.
I mean, yeah, I mean, shouldn't it be like what did that business do for Cardano or the community? That should be evaluated, because the company itself, or whatever, say this proposal itself could grow very big, but not like give the return on investment for the initial investing DAO or project.
Could you say that again?
Oh, I'm just saying some companies, like say for example, a proposal is passed. This company could grow really big, but it might not give the return on investment for the initial investor. is what I'm saying.
Right. It could not, maybe it made some money, but it didn't return anything to Cardano.
Yeah, yeah. The company is
Yeah.
successful, but it might not have given back the returns.
Yeah, exactly. Like that could happen. But the thing is, if you're funding stuff, on average, we want them to return on investment to be more than one. So if Cardano is giving you $50,000 on average
Mhm.
through all proposals, on
Mhm.
average, that should mean Cardano should be getting back more than $50,000. And currently, I don't think it is.
But currently, there's no way to figure that out also, no?
Yeah, there's no way. I think long term, it's pretty simple to just look at the price of Cardano as the return on investment. If you can kind of take out the noise and the volatility.
But isn't Cardano a complex system, so we can't like necessarily break
Oh,
it
yeah.
into parts and say,
Oh yeah. Or you can just have a very basic model to tell you that. And that's it. But I think like if this is above one, like it's going to be really above one, then you'll be able to tell that this is the case. But really, like, how do we measure this? Is a very interesting question. But the idea is pretty simple. You guys follow the idea on how this works, right? You want return on investment more than one. So we want value added by a project, value spent by the ecosystem. It's bigger. Right. Then this is also an important point. It's like mission and values of the proposals should be aligned to the ecosystem. So you don't want someone to come and dig under your ecosystem. And I think there are some good lessons to be learned from the sustainability loop, which is, was it here? No, it's the ocean system. With this model, the key thing, I think, is once you generate your token, you got to think long term because your token is your stock. So you're going to be selling your token over time. You don't want to sell it immediately. You want to build in good vesting systems so that you'll be getting token 2 years, 3 years, 5 years, 10 years down the line, so that you can safely assume that you will have the money you need in the future to build. Which is, I guess, what Catalyst is trying to do right now. Any ideas, thoughts on this Web3 sustainability loop?
So just from a bird's eye view, this the 3 variations or 4 that you have look fairly similar, right? The orange, blue, green, and purple one. Can you just give us a high level of what the main differences are between them? These are different approaches to tokenomics, or am I
This
saying
is for the orange is for companies, how companies work. The blue one is for governments, and the green one is for token ecosystem.
Okay.
And at a high level, they're very similar.
Okay. So another remark around this, and especially about the term, a fair launch versus distributions or purchases or IPOs or something. Is this something that these models concern themselves about, or not so much?
Could you expand on fair launch? Not familiar with the concept.
So fair launch, for example, is the fact that you're not selling tokens. Bitcoin was a fair launch, as opposite to most everything that's started with an IPO where people can buy in to subsidize building the ecosystem. So this is just crypto common, common knowledge. You've never heard of fair launch?
No, I have not.
Okay, so
But-
this I was just phrasing it in the most simple way that I know it out of common sense of what I've heard in hours of YouTube's. So fair launch is like when Satoshi turned on Bitcoin, he didn't get any Bitcoin for himself that he didn't mine with proof of work. You
Mhm.
know, not one unit of Bitcoin was offered or sold to anyone.
Right.
And it's distributed, and then miners, all the Bitcoin that came into existence came to existence through the power proof of work that miners put in, and then they started selling their rewards, and that's how Bitcoin comes into circulation. It's a lot different than now. For example, we say we have an organization and we're going to create. I think even Ethereum went through initial IPO, initial ICO, initial coin offering or something, where they go to venture capitalists and they say, we want to make this project. We would appreciate if you guys want to buy a few units or a few thousand units of Ethereum at $1 per Ethereum or something. That's an ICO. And that was the rush, the gold rush of the 2017 bull run. Yeah, you see
So-
there that type of diagram where you have all the pie charts. Mostly all of them were that pie chart didn't come to existence in a fair launch like Bitcoin. It was initially said, okay, we're going to have 45 billion of Cardano, and 80% of that's going to go to the community. Can we see Cardano on that one? No, Cardano is
No.
yeah, it's usually neglected,
Cardano.
but
Yeah, Cardano
Yeah.
doesn't exist
Anyway.
on those.
yeah, the difference is basically that how you and this relates a lot with how the SEC, the securities regulator in America, or some other big governments are going to rank a coin or a token as a security or not, if they're going to go after it or something. So that you've probably heard of the Ripple process proceedings, where Ripple is being sued by the SEC because Ripple was one of the ones that they were able to go after, in a suing them kind of way. Do you see there, for example, Cardano is public.
Mostly public.
Yeah. And you
Mostly
see
public.
Solana, for example, it's
Nope.
half for the insiders. And then there's community allocations in green. There's a huge difference between things like Ergo and Cardano in this aspect, and in Polkadot's like in the middle. Then you have ICP, for example. A friend of mine told me that they were offering him ICP on the shopping mall where he went. There was already someone, like the same way you see people promoting credit cards. Now they're starting to have people promoting ICP because it's very venture capitalist started. And in the end, where you see the public one, so in ICP, it's just the blue part. You see ICP is the internet computer on the bottom right. Yeah.
Yeah.
And then, for example, near, it has a very small slice of blue. So those for me are big no-nos.
Right. So this is very interesting within this context. So what this tells you is you want your token ecosystem to be sustainable over 5 years, 10 years, 100 years. What you want is to have network revenue that feeds back into your treasury so that you can spend it on your or your workers who maintain and develop your ecosystem. And you have network revenue that you can feed in, or you can feed in tokens that you disperse over years, decades, or centuries. So once you have that idea, right, let's assume, I don't know much about any of these launches, but let's assume that they launched 100% of the tokens at one time, and that they sold it, like Cardano just sold everything in public, like just forego stake pools and all of that. If that was the case, Cardano just had foundations and more. Like this is Cardano Foundation. Let's say that's the company, that's the building. Like they would have just 19% for building Cardano forever in that scenario. Like they would have to manage that 19% without any additional network revenue, just with that 19%. In a scenario where you have network revenue that's feeding in, then you have some of this feeding back into your to the foundation, to IO, so that they can keep building. So this definitely, like how you distribute your token, is very important in how sustainable your ecosystem is. But I feel like the important bit here is the insiders. Does this mean it's being built? Is
Like the
for,
founders or something. Yeah.
if it's their pay, like this is huge. Like they own half the network, then they're gonna dump on everybody else. When it's foundations, I'm thinking this is more like to develop the ecosystem. Then that kind of falls into here. So you can, for example, say Terra, let's say 44% for different. Oh, wow, this is silly. Like you didn't give anyone anything to anyone else, and people bought this stuff. No wonder it crashed. Let's not give Terra example, bad example.
Yeah.
Let's say Solana. Okay. So community allocations in public is more or less the same thing. It goes to the public. So foregoing that, for foundations, they have 13%. They're going to use this money here, token generation, for the development of Solana. So they can lock this up with a vesting period and say, we're going to unlock 1% of this every year for the next 100 years. And that's going to feed into grow the network. And you can do it in many different ways. You can set this up in so many different ways. Like this public bit, for example, maybe so that it's unlocked over 50 years. That's a model. It can be unlocked immediately. That's another model.
I dropped the plan for issuance of Cardano in the chat. If you can take a peek, just out of curiosity. So if you scroll to this monetary expansion and treasury section, this is the typical chart that you see for projects, not this one, the one, go on, that one. So this is a typical chart where you see how much Cardano is still left to be issued. I'm actually going to use this in the branding of my project. I'm calling my project 45B because it has this significance the same way Bitcoin has 21 million. And you see there, for example, most of the purple part, the community part, is already issued. Then we have the IOG, the Emurgo, the Cardano Foundation. You see there, it's probably just the 2% that we were seeing on the other diagram. CF only has 2%, which is the green part here. And now for the coming 10 years, 15, 20 years mostly, we're going to see the issuance of staking rewards and treasury growing. So I'm not really sure where the treasury money is coming from, but I'm guessing it's projected to be coming out of the fees of using Cardano, right?
So IO, Emurgo, and CF got their funds at the beginning, and they're not getting any more network revenue.
Yeah, I'm really curious to find the beginning of this chart. So I'm going to need to research that a bit.
So within that model, what they did was they took out network revenue as a method of getting more money to spend. So they're depending on an increased price of the token to spend to make this ecosystem sustainable. So it is a risk. Like we're probably not getting the full picture here, but this is a massive risk that they're not taking any staking rewards. Like they will probably be getting some of this since they're also doing staking. The treasury, I think it's the Catalyst treasury, so it's not theirs. So IO is using some other source of income to develop. Emurgo is using some other source of income because this will deplete. If your token doesn't go up, token value doesn't go up, this will deplete. This is a limited resource. You're not making income out of this. And as long as you're not making income, you're not truly sustainable unless your token value goes up. If it goes up, then it's fine. But, that's just saying like you have to be a Ponzi for it to be sustainable. Like a Ponzi that doesn't break. Like the token value just has to go up for you to be successful.
Comes down to real use, right?
Exactly. Well,
Uh,
it is a good incentive as well, I think. Like get this thing rolling fast, or you run out of money. Right.
People are going to dump it. Yeah.
Yeah.
Sebastian also dropped in the chat something with the ICO of Cardano, apparently. So we did do search for investors and etc. Sebastian, do you want to say something about this, or?
I don't think it has the investors listed. For what I know, the ICO happened only for registered investors in Japan. It was actually organized by the people that later created the Murgo. And that is the relation there.
Okay.
So for us, this is gonna be an adventure in deciding. Like Gimbal Labs, they're doing something crazy with this, where they just locked 99% or something of their token up front, and they're deciding like within their ecosystem how to do the next round, and the next round is exponentially more a larger pot. So if they're doing 1%, the next they're doing like 6%. We could do stuff like that as well. It could be very interesting how to set this up, but it has to come as like a holistic part of the strategy to make everything sustainable.
Mm-hmm. Yeah, very tricky, but it's really interesting to have that tool for the simulation. I'm not sure if it's very, very reliable. How you know, on a high level, I'm sure it's interesting, but when you get to this more the release plan, etc., if you can model that, for example, in the tool, and simulate cases of revenue or not revenue, how our services are being paid for or not by third parties. So it's a lot of ramifications. Right?
Which tool are you referring to?
The one that you were demoing just now.
This one?
No, the one that has some algorithms and capital going in and out.
Machinist or mechanisms.
The machinations.
Yeah.
Somewhere here, right? This one. If you guys missed it, this is the tool. Awesome tool. Please, someone learn it, teach us.
Mm-hmm.
And if not, learn these stuff, which are more boring, but whatever. All right. The final one that I took a look at was this one, which was the most interesting one out of all of them because it was totally new to me. And this is a very short one. I suggest all of you go ahead and read this one. It basically is just this long. It's like 5-minute read. But basically it says it's about crypto network governance as capital. So what do you understand when say governance or capital? Well, let's try to think about those concepts. What do you think capital is? And look away.
Well, I've heard this huge conversation about capital being actual productive assets like factories, cars, or even, I don't know if gold can be considered capital, but it's surely, in that case, the person was distinguishing money from capital. Harsha?
Yeah. I agree. Like, you know, the different forms of capital is something that we just like went through, right? Did you ask a question? Like I totally was thinking of something else.
Yeah, I was just asking for your second opinion on this, and it's great that you point that out. Yeah, capital is real things that we can have.
Yeah,
it's very diverse. Money is not capital in that sense.
I agree. Money is like one of the forms of capital, but that is what like is confusing me about how we convert like other forms of capital into like something that we can put on a computer and say, this is what it is, like modeling the system itself. Yeah.
I'm also curious about Sebastian, since you've studied this type of topics, right?
Yeah. I mean, Sebastian would know best because like, I think Sebastian knows Haskell and this is what they do all the time, like convert everything into functions.
I know very little Haskell. So, but yeah, capital is anything that you can use to produce, and money is only considered capital when it's used in a productive activity. So the reason why banks and insurance companies are so important is because they recycle money as capital inside an economy. And that's how that happens.
That sounds great. Yeah. It's like, I think, by the way, since we're here talking about this, I think we should have sort of like basic resources of literacy on these topics. Probably I imagine Littlefish already has them planned out somewhere, but this notion of capital versus money is really important, I think.
I agree. And specifically when we are considering reward systems, it becomes extra important, I think.
No, for sure. So one thing that popped up like 1 month ago or so in philosophy channel in Discord was this idea of 8 forms of capital. So usually, let's actually go ahead and Google what capital is and see what it is. Capital meaning. Now it says, wealth in the form of money or other assets owned by a person or organization or available for a purpose such as starting a company or investing. Basically, money or assets is what it says. But we found out this article, right? 8 forms of capital. And this comes out of regenerative agriculture, which has many parallels to like holistic systems design. These guys have like very matching values to us. And they come up with this, right? They came up with 8 forms of capital. Rather than just money or financial assets, that's just one category. You have materials, you have social capital, your relationships, you have spiritual capital, you have intellectual capital, that you know stuff, even that is your capital. Experiential, you know stuff just by experiencing them. You've taken action. You have cultural capital, that's your culture, that you have living capital, so your land and your trees and your animals and such. So like this is a more comprehensive idea of what capital is, rather than just wealth or assets. Because if you can see, like all of these can be turned into financial capital. All of these can be converted into money in some way or some shape or form. But what this does, in this article, it goes a different way. Kind of takes a look at capital as the power to organize the economic resources of a social system. So it just equates capital to power. And when you think about money in that way, it does follow so that you have more money, you are a capital allocator. That's what it's called. Elon Musk is a great capital allocator, is what they say. Or Jeff Bezos is a great capital allocator. Because they make more money, they allocate that capital. So capital is worth a function of how much of those resources can be directed to the holder's benefit. And taken together, tokens with governance rights are new kinds of capital assets, which means once you have those governance tokens, that's your political capital. So what does the idea of political capital, does that resonate with you? Or what does that bring up? The idea of having political capital.
It sounds like influence to make your products sell more than others.
Now, when you think about it in government, like an MP, a senator, a parliamentarian who has built up all these relationships. They have political capital, but you can't really account for it, can you? There's
I mean,
no
if
way
we look
to.
at their bank accounts, we can.
No, yeah,
No, I'm
there's
joking,
an
I'm joking.
indirect. Yeah, it's not a joke. It's more or less true for some, at least. So there is no way to account for that political capital rather than it exists on just a qualitative measure, not a quantitative measure. But what this article talks about is like, you can actually quantify it now. Governance tokens, that is your political capital. Let's go back into it. Does that,
Yeah,
how do you
that
guys
makes
find
sense.
that idea? Let's see. Okay. Right. All right. So the guy, what was his name? Joel? Oh yeah, Joel Monegro, right? He says capital is governance and all forms of capital exhibit its property. He gives examples. Let's see. All forms of capital provide control over the distribution of economic resources across a group of people. That means governance over the pool of resources. So once you have capital, you govern the pool of resources. Examples: productive and human capital gives you influence which goods and services are offered. Financial capital, you determine distribution of purchasing power. Political capital, you govern the rules of markets or govern whatever else. Social capital, this drives human behavior. So all these different types of capital have governance power over these pool of resources. And he says the value of a system's capital is proportional to the value of the resources it governs, and gives examples. Corporate equity is also the voting power, and it's the value of a share of stock. It's the right to a piece of the company's book and profits. It's assets under power. So you have more shares of the stock, you have more power to decide where that company goes. You have voting power.
That's really interesting because usually, in banking, in wealth management, for example, you usually use assets under management everywhere. It's like it's a measure of how much capital or money the wealth management bank has acquired and is managing. So it's really interesting to see assets under power instead of assets under management.
There's also an example in the intangible realm, which tells you what is the global cost of corruption. And it's estimated by this study by the UN to be 5% of the economy. So 3.6 trillion a year. That is an insane amount. And that tells you like the value of political capital, which again, we can't really quantify until now. The article also goes into the crypto economic circle, but can't quite recall what it's about. All right, there's the two pillars of trust in a crypto network. First is the crypto economic model of how it works, which are the rules of the system. Like, what is the unit of work? How do users pay? How miners are compensated? What is the token supply model? That gives you the crypto economic model. And there's also the governance model. So once you have both of those that work, you have a trustful crypto network. So earlier on, we were talking about Dogecoin, and the crypto economic model there is not trustworthy. So we're not thinking about it as a trustworthy crypto economy, but maybe it has amazing governance model. It doesn't matter because the crypto economic model is a Ponzi. And the governance model tells us who has the power to change the rules, under which conditions. And this is important. So you need both to be healthy. And this is, I think there's lots of parallels here with the actual governments, how they work. You have to have a great economic model. And in those systems, the economic model changes much, much more frequently. And the governance model is, yeah, leaves more wanting, to say the least. And this connects back to assets under power. I'm kind of blanking out on what this this article was about mostly, but the general idea of capital being governance, is being equal to governance, is a very interesting idea. And there's this entire Bankless episode, if you want to jump into that, that he talks about this idea.
Yeah, we'll surely put that one on play. Although I had unsubscribed Bankless a few months back when they said they're just gonna go continue ignoring Cardano and etc. It felt a bit. I'm biased, obviously. It's just a side.
I recall they had a little chat on Twitter about Charles. It's like, oh, should we invite Charles to Bankless? And Charles said, yeah, let's do it in July. But then I didn't see anything happen.
Yeah,
I was really looking forward to that one.
Yeah, I think they're a bit snobs, but it's just an opinion, obviously. But yeah, but I did follow some of their content, and especially about NFTs, Web3, different publicity models slash monetization models when everything is token based. So imagine a Spotify where no one really has to pay a monthly fee. They just listen and pay as they listen for it. The publicity models are going to change a lot. So they were covering those type of contents quite interestingly. But yeah, I'm going to take a look at that article. Thanks.
So yeah, definitely check that article. But that was all that I studied. And we're now, I think.
You studied a
getting-
lot, Chakan. Like, I don't know where you're getting, like, I don't
Yeah,
know how you guys manage
congratulations.
it. Yeah.
Thanks.
Yeah,
Thanks for
I had
sharing.
like, thank you, of course. Now we're gonna do these study sessions for, I think this is a good place to finish this one. So I'm gonna stop the recording.